welcome to Unit 15.2 of this training module on hot water treatments for seed health. In this unit, we'll focus on contamination thresholds and detection. We will explore where pathogens are located in the seed, what thresholds are used internationally, and which methods are available to detect seed-borne pathogens. Pathogens can be located in different parts of the seeds, and this strongly influences both their epidemiological importance and the possibility of eliminating them from the seeds. They can be biotrophs, such as viruses and some fungi that are obligate parasites. They will not kill their host. They often have a narrow host range and typically are localized in the embryo. Necrotrophs, in contrast, kill host cells and feed on the dead tissue. They usually have a wider host range, can be cultured, and are typically found in the seed coat or in the endosperm. Understanding this distinction is critical as it determines whether a pathogen remains latent risk or can develop into an active disease problem in the crop. Here I have listed some of the examples of the pathogens that can be located on the seed coat. On the seed coat, we often find bacteria such as Xanthomonas campestris, pathocampestris. This is a black root in the crucifers. And for example, Pseudomonas syringae, pathova tomato. This is the bacteria causing bacterial speck in tomatoes. Fungal pathogens like Alternaria, Cladosporium, and Botrytis are also common, as well as tobacco mosaic virus. Within the seed coat, we may encounter some Fusarium species, Verticillium, Colitotrichum, and also tomato brown rugose fruit virus is located on the seed coat or directly under the seed coat. Pathogens in the endosperm, again, some of the Fusarium species causing wilt, but also root rots of different crops. Fungi like Aspergillus, Penicillium are also located in the endosperm. Pathogens in the embryo, highly relevant pathogens include, again, some of the Fusarium species, some of the Colitotrichum, some of the bacteria like Pseudomonas that causes halo blight on beans, or Xanthomonas campestris, pathoresicatoria, causing a bacterial spot in peppers and tomatoes, as well as some of the viruses, for example, tomato mosaic virus and also tobacco mosaic virus. International and national guidelines are there to define the thresholds for these pathogens and or let's say thresholds for acceptable levels of these pathogens on the seeds. So for example, the lettuce mosaic virus has a zero tolerance in USA and Australia. 0.1% of the seeds in one seed lot can be infected with lettuce mosaic virus in Europe. Xanthomonas campestris, pathocampestris in brassicas has 1 in 30 seeds are allowed. By Fomalingam in different brassicas, 1 infected seed in 10,000 seeds is allowed. Ascojita faber in brood beans, 1 in 60 seeds can be infected. Xylhydrocladium parasiticum, it's a pathogen of peanuts. There, 1 in 400 seeds. Seed health testing has 2 main goals. The first one is to identify relevant pathogens on or in seeds and also to quantify them. And for seed health tests to be reliable, it must meet several criteria. It has to be sensitive, meaning able to detect pathogen even at a low concentration. It has to be specific, meaning able to detect targeted pathogen in the presence of non-targets, for example, in the carrots, to detect Alternaria daudzi in the presence of Alternaria alternata, for example. It has to be quick or speedy in order to provide results with a reasonable time frame. It has to be reliable. It means unaffected by a slight variation in the test conditions. Repeatable, it has to have a consistent performance, and has to be reproducible. It means transferable, consistent performance across different laboratories. And very important, it has to be cost effective, which means it has to remain feasible for routine application. Different methods are applied depending on the pathogen group. Here is the table summarizing the most commonly used detection methods for different groups of pathogenic organisms. You can see that some of the methods are fitting for one group of the pathogens, like visual examination, but some tests, like for example, PCR, can be used to detect all of the organisms. Here's an example of blotter test. This is also the test that we are using for the detection and quantification of the fungi-infected seeds in Bingenheimer Saatgut. And the blotter test is usually used for the fungal pathogens, and they are inexpensive, versatile, allow direct observation of viable fungi. But at the same time, there are also limitations, as the only small seed samples can be tested, and a considerable expertise is required for the accurate identification. So to ensure comparability and reliability, seed health tests are often based on standardized methods. And these are, for example, methods that are published by International Seed Testing Agency, ISTA. Here is the screenshot from their website. But beside the International Seed Testing Association, there is also the International Seed Federation and also the National Seed Health System in United States. Following these protocols actually ensures that results are accepted internationally and can be produced across different laboratories. So to summarize, pathogens can be located in the seed coat, endosperm, or embryo, and this determines both risk and treatment options. International national thresholds for seed-borne inoculum vary by pathogen and reflects their epidemiological importance. Effective seed health testing must be sensitive, specific, reliable, and cost-effective. Methods such as blotter test, agar plate methods, or molecular assays are commonly used, with ISTA protocols providing standardized procedures. Reliable detection and thresholds-based decision making are essential prerequisites for deciding whether hot water treatment or other measures should be applied. In the next unit, we will turn to the process of hot water treatment itself, and we'll look first at the general consideration in the workflow at the Bingenheimer Saatgut. Thank you very much.